Hi students, we are seeing quantum mechanical model of an atom. In that we are going to see about exchange energy. We have studied the quantum numbers and about the orbitals. We know what is quantum numbers. Quantum numbers explains about the position and the energy of the electron. We know that we are having 4 quantum numbers. Principal quantum number, it is denoted as n, and azimuthal quantum number, it is denoted as L, and magnetic quantum number, it is denoted as M, and spin quantum number, it is denoted as S. And also we know about the orbitals. We are having 4 orbitals: s orbital, p orbital, d orbital, and f orbital. In order to explain the exchange energy, you should learn these 3 terms. One is completely filled or fully filled, the second one is half filled, and the third one is partially filled. Okay. So let me explain what is completely filled electronic configuration and what is half filled and what is partially filled. We know to write the electronic configuration for an element. Okay. So here for s orbital, 2 electrons can accommodate in s orbital. So the completely filled orbital is 2 electron. So half filled in the sense we will have only 1 electron. So for the same thing, for the p orbital, the completely filled electron is 6 electrons and half filled means 3 electrons. For d orbital, completely filled is 10 electron, for half filled means 5 electrons. For f orbital, completely filled electron is 14 and the half filled is 7. Okay. So whenever it is completely filled or half filled, that is said to be most stable configuration. Okay. So we are having, I have drawn the degeneracy box for fully filled, half filled and partially filled. Let me fill this with electrons. Fully filled in the sense I have taken d orbital. Only d orbital will have the 5 degeneracy sets and d orbital will accommodate 10 electrons. If the d orbital accommodate all the 10 electrons means that is called fully filled or completely filled configuration. So let me write the electrons: 1, 2, 3, 4, 5, then 6, 7, 8, 9, 10. So this degeneracy set is having 10 electrons. So this is called fully filled or completely filled degeneracy set. Then go for the next one, half filled. Half filled in the sense I have written here, I have taken d orbital. For completely filled mean 10 electrons, half filled in the sense only 5 electrons. So let me write the electrons here: 1, 2, 3, 4 and 5. Only I can have the same spin electrons. Okay. This is called half filled electronic configuration or half filled degeneracy box. Okay. It is having only 5 electrons. Then the last one, partially filled. Partially filled in the sense it does not have completely filled or otherwise it does not have half filled configuration. Let me write here, say for example it is d orbital, I am writing only 3 electrons. So it is partially filled because the 2 degeneracy box here, it is left empty. Okay. Do you understand? So the next one is, we will see what is exchange energy. If 2 or more electron with the same spin are present in degenerate orbital, there is a probability to exchange their position. Okay. Here you should know what is same spin. Let me write the example here itself. I am having one degeneracy box. I am filling this with an electrons. Okay. Here this one will have the plus half and this one will have the minus half. Okay. Here what they are saying, if 2 or more electron with the same spin in the sense only one kind of spin, positive means only positive. Okay. So let me explain that here. Okay. It is having plus half and it is also having plus half, it is also having plus half, the same thing it goes on. In this case only the exchange energy is possible, and also these same spin are present in degenerate orbitals. We know what is degenerate orbital. Degenerate in the sense the orbital is having the same energy. So, it is called degenerate orbital. Okay. This is the definition for exchange energy. When this has happened, energy is released. That energy is called exchange energy. Let us explain that exchange energy with an example. So, I have taken d orbital as an example. So, I am having half filled configuration. So, I am writing 5 electrons in each set. I have written 1 electron. So, it is having the half filled configuration and it is having the 5 electrons. But this time this is called first electron, this is second electron, and this is third electron, and this is fourth electron, and this one is fifth electron. So, this first electron is having the probability to exchange its position with the second electron. So, let me draw like this. The first electron is having the probability to exchange its position with the second electron, and the first electron is having the probability to exchange its position with the third electron. The first electron is having the probability to exchange its position with the fourth electron, the first electron with the fifth electron. In this way, I can exchange the energy of the first electrons with the second electron, third electron, fourth electron and the fifth electron. So, the number of possibilities or the number of probability will be the first electron to second 1, 2, 3, 4. So, the first electron will have the 4 probability to exchange the position. Say for example, we will go for the second electron. So, the second electron is having the probability to exchange its position with the third electron. So, second electron with the fourth electron, second electron with the fifth electron. So, I did not draw the line for second to first because already the first electron exchanges its position with the second electron. So, I should not draw from here. Okay. So, the second electron is having how many exchanges? 1, 2 and 3. So, the second electron exchanges will be 3. For the third electron, let me draw here third electron with the fourth electron and the third electron with the fifth electron. So, for the third electron, I am having 2 exchanges. Okay. Then for the fourth electron, let me draw here, fourth electron is having only 1 exchanges. So, let me write 1 here. So, in this way I can explain how the electrons can exchange their position with other electrons. Okay. So, let us take one example here. I have taken chromium. So, the atomic number of chromium is 24. So, this is the actual electronic configuration. You know how to write the electronic configuration for an element. Okay, I have written the actual electronic configuration for chromium. So, here what is the orbital they have given? D orbital. D orbital in the sense we will have the 5 degeneracy sets. This is called degeneracy box or degeneracy set. Okay. So, since it is a D orbital, I have to fill the 4 electrons in D orbital. Let me fill the electrons first. 1 electron, electron 2, 3 and 4. I have completely filled all the 4 electrons. So, the last degeneracy set is left. Okay. So, this is partially filled. Okay, it is not completely filled, this is partially filled. So, let us see the exchanges for these electronic configuration. Okay. So, the first electron exchanges its position with the second electron. So, this is first electron, second electron, third electron and fourth electron. First electron with the third electron and first electron exchanges its position with the fourth electron. So, we are having 3 possibilities for the first electron. For the second electron, second with the third and second with the fourth. So, we are having only 2 possibilities. So, the last one, third electron with the fourth electron, only 1 possibilities. If I add the number of exchanges, I can get 6. I can have the 6 number of exchanges for this example. Let the same example I am writing here. Here, in order to attain the stability, one of the electron from S orbital is shifted to the 3D orbital. Here we are having 3D4 in the sense it is partially filled, and in order to attain the stability, half filled configuration, one of the electron is shifted to D orbital. So, we are getting 3D5 and 4s1. So, this is the electronic configuration here. So, let me write the electrons here. Electron 1, 2, 3, 4, 5. So, I write the number here 1, 2, 3, 4, 5. The same thing whatever we have seen here, that will going to happen here. So, one electron shifted here, the first electron with the third electron, and the first electron with the fourth electron, and the first electron with the fifth electron. So, for the first electron it is having the 4 exchanges. For the second electron is having the possibility of exchanges between 3 and 4 and 5. So, it is having 3 possibilities. Second electron is having 3 possibilities. For the third electron, 3 to 4 and 3 to 5. So, third electron is having 2 possibility of exchanges, and the fourth electron only 1 possibility of exchanges between 4 and 5. So, if I add here, I will get 10. Here 10 exchanges are possible in this configuration. So, if the from this what we can infer means if the exchanges are more, energy released more. So, the half filled configuration is more stable when compared to the partially filled configuration. Thank you.